Hi, my name is Aisha, and I am an interdisciplinary researcher in water science and engineering. I've been researching and teaching in areas related to water for over 10 years now. In the beginning, to improve operational efficiency and costs, but increasingly, I've been looking into ways to reduce energy use and emissions from water production and use. I currently work on the interdisciplinary cross-border Dorishka Water Energy Nexus research project, which is partly funded by the Interreg Island Wales program. Dorishka stands for Dur, water in Welsh, and Ushka, which also means water in Irish Gaelic. It is also a clever acronym for distributing our water resources, utilizing integrated, smart, and low-carbon energy. The Durishka project is necessary because the water industry is very energy intensive, and up to 3% of the world's energy use is used to produce and supply water and to process and dispose of wastewater. In the UK, for example, the water sector is the fourth most energy intensive sector, accounting for around 3 to 4% of total electricity use and 1% of emissions. The water industry has been working to reduce its energy use through things like leakage reduction and use of renewable and low-carbon energy, and it sees itself as a credible pathway to the energy transition necessary for reducing emissions and achieving a net zero carbon. However, energy use of the water industry only represents just over 10% of energy use, and the rest of this is attributed to water use. And water companies can only do so much once water gets delivered to customers. So a lot of the energy use associated with water, therefore water-related energy use, is actually on the demand side, on the water use side. And because we all use water, we all have a small role to play to help the sector reduce its energy use and also to reduce our own emissions from our water use, reduce costs of water supply, use, and disposal, because we don't only pay for the water that we use. Water and energy are central to both socio-economic and sustainable development. But water is a finite resource, and both its quantity and quality are diminishing because of increased competition for water by households, industry, and agriculture, increased pollution loads, which have an impact on water quality and which further limits quantity of water availability, and climate change, which is changing the timing and availability of water resources. So the demand for both water and energy are projected to continue to increase due to expected population, demographic, and lifestyle changes, and also due to socioeconomic development and growth. So this will be compounded by the projected reduction in availability of fresh water. So as the population continues to grow and the economy continues to develop, we need to find a balance between water use and growth to ensure that everyone has what they need when they need it, whilst minimizing impacts on the environment and climate. Every step of the water system cycle, from abstraction to treatment, conveyancing, and disposal of wastewater, requires energy, and it is very important that we minimize as much energy use as possible, given the associated greenhouse gas emissions from energy use and the impacts of emissions on climate change. Now, on the other hand, energy generation also requires water, whatever the source of energy, whether it is oil, gas, coal, biofuel. And there is a need to develop more water efficient energy sources given the increasing stress on water resources. So because water and energy resources and systems are linked, the challenge to ensure the sustainability of safe, adequate, and resilient supply for everyone and for future generation means that we can no longer manage and use water and energy resources in isolation of each other, and we need to understand the ways in which they connect. And this connection between water and energy is what Nexus means. So the water energy nexus is therefore the connection or linkage of water and energy resources and all the dependencies and interdependencies between them. In the Durushka project, we're looking into different ways to improve the energy performance and long-term sustainability of the water sectors in Ireland and Wales. And we do this through the assessment of current and emerging low-carbon technologies like microhydropower, rainwater heat recovery, and smart networks, and through the economic, environmental, and climate change impacts assessments of water resources and of water systems. We also look at auditing, rating, and benchmarking of the water-related energy use of both water supply and demand. We're therefore looking into the whole water system's life cycle, from provisioning to use and disposal, to help us assess both current and emerging technologies and intervention measures that can help with energy improvements in the sector. We engage with all water stakeholders, from water companies to households, schools, local authorities, businesses, and other public and private sector bodies through our Smart Specialization Cluster, which is where we disseminate most of our research findings as well. So our main objective is the reduction of energy and emissions in the sector, mainly through a reduction in costs of water supply and treatment, and a reduction in energy use and emissions for water end users, so households, businesses, pretty much anyone that uses water. We have some demonstration sites in both Ireland and Wales, and these are pilot-scale technology installations for learning and interaction, which we hope will demonstrate the feasibility of low-carbon technology and encourage its early adoption. So some examples of the pilot technology installations we have in Wales include a heat recovery installation in the commercial kitchens of National Trust's Bangor Castle here in Bangor. And this aims to recover energy from the kitchen wastewater to be used to warm incoming cold water to the kitchen. We've also looked into other applications of heat recovery in other sectors, for example, food and drink and the leisure sectors, and you can find more information on these and more on our website. We also have a micro hydropower installation for energy generation at another National Trust property at Chimawa in Snowdonia. And this was the birthplace of Bishop William Morgan, the first translator of the Bible to Welsh, and this is where one of the Bibles is kept. So the Timawa installation is expected to generate about 19,000 kilowatt hours of clean, renewable electricity from the water of a nearby stream every year, saving over 5.3 tons of CO2 emissions every year. And the main purpose of this installation is to demonstrate not only the environmental benefits of a small-scale scheme like this, but to also show the economic feasibility of small-scale hydroelectricity generation. So the Timawa installation was officially launched in November 2019, and you can find more information about it from this article here or by watching this video. My research on the Durushka project is looking into some of the key water demand areas in the built environment. So in homes, in schools, in offices, and in leisure centers. And this is helping me to better understand how water is currently being used in these different environments, the water-related energy use and associated emissions of these types of water demands, and the potential for emissions and cost savings through better water management and water use efficiency. So my work mainly involves the auditing, rating, and benchmarking of the current water-related energy use in these areas. And it's helping me to quantify their emission savings potentials and their cost savings potentials, which I am using to develop policy and best practice guidance for different water users. Well, the built environment accounts for 40% of the UK's total carbon footprint, and a lot of this is from water use. Recent research found that up to 86% of energy we use at home, for example, is used for space and hot water heating. And the energy used for this is mainly from burning fossil fuels like oil, gas, and coal. As you can see from the breakdown of energy use in buildings by the Climate Change Committee, households account for the majority of energy use and emissions in the built environment at 77%, followed by commercial buildings at 14% and public buildings at 9%. And in terms of household water use, and therefore household water-related energy use, research shows that it is possible to achieve the average water consumption of between 50 to 70 litres per person per day, compared to the current 150 litres per person per day within the next 50 years in the UK, without a reduction in service level or quality. So given the potential of significant reduction in water use in the built environment and what this will mean for energy use, water energy efficiency can be an accessible and inclusive way for everyone to take climate action and improve their carbon footprint. And this is something we can all start doing immediately, and it may even surprise most people how well they're already doing. And this also makes economic sense, especially given the current energy and other crises that we're going through, as it will help us save some money because we use less energy when we use less water. Both water and energy bills would be lower if we use less. So how exactly do we use water at home, and how does this relate to household energy use? This is a breakdown of an average household water use, and it helps with understanding of where water and water-related energy savings potentials are. So less than 5% of the water we use at home is used for cooking and drinking, and almost a quarter of treated and clean water is flushed down the loo without performing any other meaningful function. We also use almost 40% for bathing, and the rest is used for cleaning and outdoors. In terms of hot water use, we use this mainly for bathing, cooking and drinking, laundry and dishwashing. But even cold water that we flush down the loo has had a lot of embodied energy and carbon from the abstraction, treatment, conveyancing, and wastewater disposal processes. In terms of household energy use, most of it is used for space heating and hot water use. As you can see, about 83% from this figure here. And we saw earlier of the more recent research that shows that we could be using even more than this figure shows, up to 86%. But there is some encouraging news. The general trend is that we are using less water than we did even 10 years ago, which is great, but there is a lot of potential for significantly more reductions. And even as we are flushing less water, as flush volumes have progressively reduced, the trend for power showers, pressure washers, hot tubs means that we are using a lot more water for bathing and cleaning than we used to. So how can we help with all this? How can we reduce our water and energy use and help take climate action through water use efficiency? Well, there are many simple actions we can take at home, at work, in school, everywhere and anytime we use water, really. And many of these actions are easy to do and have zero or very low cost, as they are mostly behavioral. And even the ones that, cost quite a lot of money seem to have quick payback periods compared to how they used to. So for example, consider our bathing habits. Think about your own bathing and shower water use. Bathing habits have changed. More and more people have showers now instead of baths, but some showers actually use more water than a bath would. So showers may not necessarily be more water or energy efficient than a bath if we're using power showers or taking longer than necessary showers, even if we're using efficient shower heads. Another simple way to change our water use behavior is to remember to not leave taps running whilst brushing teeth or shaving, or when dishwashing or washing fruit and veg. And other actions include fixing leaks and faults immediately. So not just pipes, but dripping taps and leaky loos as well. Even an efficient 6 liter per minute dripping tap can waste over 5,000 liters of water a year. And a leaky loo can waste around 400 liters a day. And all of the energy that went into producing and supplying that wasted water is wasted as well. Other actions include replacing white goods, so dishwashers and washing machines, with more water and energy efficient alternatives when it comes time to replace them. And installing water meters help because it helps you keep track of exactly how much you're using, and smart ones provide better information as well. So if you don't already have a water meter, having one would help you be more efficient. Think about your energy supply in use as well. If you're able to switch to a renewable or low carbon energy supplier, that would make a difference. In terms of using technology, any renewable energy or low carbon technology like solar PV, heat pumps, or heat recovery systems would help. And the payback periods for some of these technologies can be quite reasonable nowadays. So thank you very much. And you can find more information about Durishka and all the research we do in all the sectors and the results and findings from our work on our website.